We're group 11 for senior design project, and for our project we're doing a virtual CNC panel. My name is Matt Butler.
I'm Eric Schilling.
And I'm Gunnar Mills.
And our project was made for Noom Corporation in Naperville, Illinois. Okay, so Noom is a CNC manufacturer where they create both the hardware and the software in-house. And the motivation for the project was mainly they have these big machine panels like you see here on the very left, which are very clunky and look somewhat outdated. Now they came up with their own solution a while back, is what you see in the middle here, a mobile device that operates through Wi-Fi to control their CNC machine. The problem with that is it's extraordinarily expensive to produce this type of device, and a lot of times the hardware is not available to everybody. So to create an even better solution, we decided to make an Android application that can control the CNC terminal and would act as the CNC panel you see on the very left. So kind of our brief requirements for this application was to replicate the existing CNC panel and recreate the panel on an Android device. Before they were using Wi-Fi for their portable device. Now we're going to be using Bluetooth. And then we also wanted to make sure that we had to provide a cost benefit to both Noom and their consumers. So there's a little bit of hardware we initially had to custom ourselves with just to start the project. This is an example of what a typical CNC assembly would look like, with a lot of different moving parts. But this is just a demonstration of a sample configuration to have. As you saw on the slide before, there was nothing to interface with Bluetooth connections. So in order to complete this project, we had to purchase a Bluetooth interface, which is called CAN Bluetooth, and that sits on the CAN bus line. And then we had them also purchase a tablet for us that we could test and develop the application on.
So this diagram kind of shows where the CAN Blue device integrates with their existing system. It sets on the CAN bus network and then communicates through Bluetooth to the Android tablet. So before we talk about the actual development of the project, I will mention some of the tools we used. We use Java with Android libraries, and we use Git, source tree, GitHub for our version control. We use the Android Bluetooth API to communicate, and we use the Eclipse integrated development environment to actually develop the software.
All right, just a quick kind of overview of how the development went. So the first week we went for a training session to see how CNC machines generally operate and how where our piece would kind of fit in and how it would work. Then we needed to order our parts, which Matt talked about, which is the Nexus 10 and the CAN Blue, and we also got the same software packages on our computer so that there was no problems with versions of Eclipse or anything like that that we were using. And then the next few weeks, basically what we had was we only had the tablet for the first few weeks, so there was a big leg done in getting the user interface operational, and basically none of us had used any Android development before, so just getting even the app on the tablet to work was a little bit of a challenge. But this is where we did a lot of our user interface development, and this here is one of our prototypes for our user interface here. And then moving on right before the first checkoff, we had to assemble our test stand, get our CAN bus on the CAN bus line and install the drivers for that. And then we connected a PC to the CAN Blue to make sure that our CAN Blue was operating correctly, and we were able to transmit messages as well as receive at this stage. And then what we used to check to make sure that it was working was there's a program called Minimon that we were able to send messages to and see it displaying. But I guess at this point we weren't really sure exactly if the messages were going to be working due to a lack of the actual machine panel. But we were able to see that we were able to send messages from our tablet to the CNC, and we could view them on this Minimon. And then this is basically what I was just talking about. This is a layout here of the mini-mon and various transmit and receive coming from our tablet, and then down here we can transmit them. And then also to test that first, we used our PC just to make sure that our CAN Blue was installed correctly. A little bit about the communication was we were able to view the data being sent, like I just said. There are APIs that were available to us, but we had to program our methods to send the correct data. We had to send stuff such as data length and identifiers, which was like this front-end information here. To actually get it to work, there was a little bit of guess and check. We weren't exactly sure which location to place the identifiers. And then also one of the cool things is that our final result lets the user program each individual button to be any button on the CNC machine panel. And this change our application to adjust toggle buttons was originally what we had was our tablet was set up to be change on touch, and we altered that to be change on receive information so that there was no gap in between what our tablet was sending and receiving between the tablet and CNC. And then for the final checkoff here, we had to adjust our application based on the feedback that we got back from our sponsor, things such as how to edit a button in the interface layout. They didn't really like how small the real estate of each button had, so just even things such as giving each individual button more real estate. We added safety features, worked on the save state of the application, and the communication, the constant communication to make sure that our tablet was up to date on what was sent and received. Here, this is just an example of kind of how we had to alter our program from feedback changes. Over there on the top left was our original edit button layout. It allows the user to put in the text that they want on the buttons, as well as select from 3 different sliders, any color basically that they want from the buttons. Our sponsor wasn't exactly for this approach, so we made it a little bit more intuitive here. They can select from 1 of 5 colors, and then as well as we came up with the design idea here where they could program in their data bits to correlate each button on the tablet with the CNC machine panel. And then down here is just some previous other examples that we had used while we came up with the final solution.
So this is the final software product. This kind of shows you the different screens you can go to. So this first one is the start screen. So when you start, the tablet automatically connects to the CAN Blue device. If it is unable to connect to the CAN Blue device, a air screen is shown. Gives you some ideas of where the air was thrown at. Assuming a successful connection, you go to a home screen. It's a blank home screen until you edit some buttons. By clicking on, there's a settings tab in the upper right hand corner. You can click and you can go to the settings page. All the buttons shake at this page, and clicking on an individual page lets you edit the individual button. So this is the application on an Android phone. I know Eric kind of talked about this, but this is some of the customization you can do. You can change the text, you can change the color, and most importantly, you can change the code that is set on the buttons. This is important because you're mapping several buttons on the CNC machine up to 18, and those may change. So being able to edit which button is mapped to which is very important to our project, and then everything's scalable.
So just like Gunnar was saying, everything's scalable. So when you load our application on, say, a mobile phone, or let's say you load the application on a tablet, everything's going to look pretty similar and everything's going to work exactly the same. We were able to accomplish this by a couple different methods. Mainly, the toggle buttons that we created for our Android application were fully customized. That meant that when a button was stretched one way or another, there could possibly be some distortion or some pixelation. Fortunately, Android had a solution to that. So we used the Android Development Tools application called 9patch, which you see right here. What that allows you to do is load in an image and specify which region of an image that you want to be distorted. So it gave us the ability to have the buttons fully scalable depending on whatever size screen the application was running on. Additional features we have in the user interface is that every button press has a vibrate when you push down on the button, it vibrates when you push up on the button. And then we also have audio for when the application starts up and when the buttons are pressed as well. Additional things we talked about maybe a little bit. We implemented toasts whenever we possibly could. What a toast is in Android is a notification to the user. So you saw on the previous screen where it said battery level 83% or so, that was a toast. So it'll pop up and display relevant information to the user when possible. We implemented toast when there was the connection at the beginning of the application, when you were saving settings, and also when it was loading save settings. Like Gunnar said before too, we have automatic Bluetooth set up on startup. So if the device has previously been paired with another Bluetooth device, upon startup it'll automatically pair again and start communicating automatically. One other thing we touched briefly on was saving state. Android has something called shared preferences. So let's say we have a technician that goes in, sets up all the buttons, has the virtual terminal set up exactly how the customer would like. We aren't going to lose all that information whenever the application is exited by the user. Whenever the user opens up the application, it's going to continue where they left off.
Some challenges we encountered. Working with a real customer takes a lot of time. We were constantly meeting with them, and they were constantly giving us feedback, and we were constantly having to change things. For example, we created a whole settings page that was really cool with all the sliders, but that wasn't what they wanted. We didn't find that out until we had built that. We also had some development issues. There was a lot of parts, moving parts, and a lot of our stuff communicated with each other, so it was hard to work in parallel at times. We also had some hardware delivery issues. We didn't get the canned blue device until almost week 4 or 5, and then just the new technologies. I know when we first saw the CNC machine, it was pretty intimidating. There's a lot of parts that go with it, and we had to really know what those parts were to communicate with them. The success and the future of the application, we're turning all the source code over to Noom. They are very excited for the application we created. They hope to market this to their large consumer base. They thought that the ease of use of this app was exactly what they wanted, how easy it was to set up, make those buttons work. And we see potentially an opportunity to develop new features for them. Thank you very much.
Thank you.